Okay, good morning class. So today we're looking at exercise 4. I think number 5, 6 and 7 we'll do in this lesson. Right, so exercise 4, number 5. Okay, so here we are told that, you make this smaller for now. You make this smaller. So we are told that in the diagram, ABC lies in the same horizontal plane. Okay? Sorry, BCD. So we assume that's on the ground. With BC equal K and DCB equal X and CBD equals 1. It means that if AB and ED are vertical to the plane, which means to say it stands 90 degrees to the horizontal plane as indicated at angle B there. Okay? And the angle of elevation from E to point F is theta. The question says right angle B, D, C in terms of X and Y. So that's the angle they are referring to. So that is simple. We know that X plus Y plus that angle equals 180. So therefore BDC is equal to 180 minus X plus Y. You can say the sum of triangles. Do I have to say give a reason here? No. Okay, so this is going to be of course 180 minus X plus Y. Okay. Let's go to the next question. Next question we are asked to show that EF, the EF is given by K sine X over cos into sine X, cos X plus cos X sine 1. Alright, as you can see that is already on the diagram, as I don't need more space here. So when we start, if we're looking at EF is lying far from X and Y. Can you see that, people? So I need to make a link between that triangle and this triangle. However, what type of shape is AEDB? A rectangle, no? You don't know it's a square. Because why? Those lengths has to be equal to be a square. So the least it can be is a rectangle. As you can see, there's 2 and 90 degrees there. So we know that BD is equal to AE. Can you see that? So, if I'm going to consider this, okay, I'm going to say in triangle, if AE, we have a triangle looking like this. This is A, which is 90, E is theta, and F. So, which trigonometric function is adjacent and hypotenuse? Cos. So we're going to say cos of theta equals AE over F. Remember the one that EF is the subject of the formula. So cross multiply, so I get FE cos theta is equal to AE and then divide by cos of theta. So FE is equal to cos, it's going to be EA over cos theta. Okay, so in other words, I must calculate AE. Can you see that, people? However, if I look at this here, I'm already seeing cos of theta on its right place. Can you see that? So I'm not going to change cos theta from that position there. Okay, so let's move this over. Then we're going to work in triangle. As I want to keep the diagram in focus, in triangle BDC, what you should see here, B, that is y, D, which is 180 minus x plus y. This angle, of course, is x, which is c, and we got k there. As you can see, there's a k as well. Okay. So what are we going to use? We must use BD, as BD is the same as AE, which is the link between the two. So we must use that. So we have many angles, so we're definitely going to use the sine rule. So we want to make BD the subject of the formula. So BD over sine of x is equal to k over sine of 180 minus x plus 1. Alright. So make BD the subject of the formula, cross multiply. We'll take that up. So BD is equal to k sine x. You see it's coming together now. Over 180 minus is in which quadrant? Second quadrant. The sign positive and negative? Positive. So is this sine of x plus? But you see that is almost the same. But what is this? The compound angle. Not so. So now we say, we use a compound angle. So k is going to be k sine x over sine x cos y. Same sign or opposite sign? Same sign. Plus cos x sine y. And you see we have that also now. So what do we do? We have to merge the two. Okay. So wherever we now see AE. But what must we say first? We say since AE is equal to BD. And why is that the case? Because opposite sides are equal in rectangle. People, do I have to give a reason here? No. Why? You're not busy with Euclidean. So this is sufficed by saying A is equal to BD. So therefore, I can replace this with AE. Can you see that? So if I see AE, I replace that AE with k sine x over sine x cos y plus cos x sine y. So you're going to go in there now. Okay, conclude therefore FE is equal to the story here, which is k sine x over sine x cos y plus cos x sine y. What's this? Okay, thank you. Thank you, Mike. Alright, so what is in the denominator here? Cos x. So I must multiply this by cos x. Not cos theta, but cos x. And is that cos theta? Did I write x twice now? Then become cos theta. And that is exactly what they have there. Not so? So any confusion there? No? So all that information that we got so far is on the board, and so you clear the board. I just want to keep the diagram in focus. Okay. And of course, the next question is to calculate the value of so in 5.3, what's up here? 3. Calculate the value of EF. So EF is this length here, not so. But EF is also defined as the stored here. You see that? Calculate the length of EF. If X is 48, so I got the X's. Y is 38. Theta is 28. And K is 13. People, I got the whole story. Not so. So from here it is a simple substitution. So EF is equal to K, which is 30 sine X, which is 48, over cos theta, which is 28, into sine X, sine 48, cos Y, 38, plus cos X, 48, sine Y. Okay. So what do I do from here? Plug it into the computer. Calculator. Okay. So what do I have? 30 sine 48 over cos 28 into sine 48 times, times cos 38 plus cos 48 times sine 38. So if that's correct, I'm getting 25.31. The length is in meters. It will be meters. Okay. Is there any confusion? It's a nice question. Then all questions are nice. People, why didn't you tell me I got a 3 here? It's supposed to have been 5. Now we had number? What kind of girls are you supposed to? Now we're looking at number 6. Pull the figure up. As I've indicated yesterday, people, these shapes are the same. Not so. Just change values. Otherwise, it's the same type of shapes. Right. We are told that in this figure alongside ABC lies in the same horizontal plane, assuming that's the canal. Then we are told that the vertical pole DC, this is vertical, so it stands 90 degrees to the horizontal, is h meters high, and the angle of elevation from B to D is theta. If CAB is alpha, ACB is beta. So that angle there is your beta angle. Okay? The question says show that AC is denoted as. So where's AC? Yeah, that's AC. It's denoted as H. So where I'm getting H, I must pick up this here. So of course I have to work in this triangle here, which is ACD. Or, but I don't have much on this, I don't have any angles here other than that being 90. So ACB, in that triangle I must work. And in triangle, I must pick this one up. Oh, here's the H in this triangle as well. Okay, so I'm going to work in triangle DCB as well as ABC. or ACB. You guys see that? And where's the link between the two triangles? BC. Make sense, people? So where do I start? I'll start with the triangle that base AC. Okay? Which is this triangle here. So what do I say? I say in triangle ABC. Drawing that triangle, you should see the following. This is angle A, which is alpha, C, and B. What's the size of this angle? Beta. Not so. So what must I use? I must use the length of AC and I must use the length of BC. Why must I use BC? The link between the two triangles. Can you see that, people? So what do I say? What do I need? Many angles are going to use the sine tool, not so. So AC over sine of this angle here. I need to know what that angle is and what's the size of that angle. Angle B, but there's many angles at B. So I'm going to say ABC. Angle ABC is equal to 180 minus alpha plus beta. Not so. So that is 180 minus alpha plus beta. Put the right in here. So if I apply the sine rule, what would it be? AC over sine of 180 minus alpha plus beta equals, what do I need? I need to use this here, no? So it's going to be CB over sine of alpha. Make AC the subject, not so. Take it up. So therefore AC is equal to CB. Now 180 minus in which quadrant? Second. Is sine positive or negative? Positive. So it's going to be sine alpha plus beta over sine alpha. Well, look at what we have. We have sine of alpha plus beta in its place, and sine of alpha is on its place. You see that, people? So we're going somewhere. So, take this off here. On the other end, we said we're going to work in triangle DBC. So in triangle DBC, what should you see? What is this? C here, B, D, D. What is this? H here, 90 and theta. What must I use? CB or BC. Not so. And which trigonometric function uses, and there's a H of course, no? Opposite and adjacent, tan. So I say tan of theta equals H over BC. So hang on. Cross multiply, so it's going to be BC. Tan of theta is equal to H. So therefore BC is equal to H over tan theta. You see? There is an H and there is a tan of theta. So what does that mean? Putting it together. Not so. So what do I say now? Therefore, wherever you see BC, I replace it with H tan theta. So therefore AC is equal to H over tan of theta. That is in the numerator, so it goes next to H. So it's sine alpha plus beta over sine of alpha. And that is exactly what you have. Okay, sum like this is worth 1, 2, 3, 4, 5, 6, 7 marks. Okay. This sum is, this section of work is normally 10 marks. Maximum of 12 marks. Okay. Average 10, maximum of 12 marks. In your paper 2. Okay. And it's easy. Is it difficult? No. so as you can see, I need the space, so that takes off. And whatever we needed to calculate anyway is on the diagram already. Okay. Alright, people 6.2. We are told that if alpha is equal to theta and beta is equal to 30 degrees, use 6.1 to show that AC is equal to that. If alpha is equal to theta, but if you look at AC, what do you notice? There's only alphas, not so. So if alpha is equal to theta, I will replace theta with alpha. So there goes alpha now, né? And beta with 30. So therefore AC is equal to H sine alpha plus 30. And this is all over sine alpha, which is alpha, stays alpha, and tan alpha. You all agree with that? Alright, so what we're going to do is we're going to use the compound angle sign. So it's going to be H into sine alpha cos 30 plus sine 30 cos alpha, or cos alpha sine 30, and it's all over sine alpha tan alpha. Okay, you all agree with that? But what I notice is that I have tan of H over tan alpha on the outside. You all see that? So what I'm going to do is I'm going to keep this on the outside. Okay? Then I'm going to get H over tan alpha into cos of 30 and sine of 30 I can use from the special triangles of 30. So it's 30 is 1, 2, root 3. So cos of 30 is root 3 over 2. So it's root 3 over 2 sine of alpha plus, that is opposite of, so it's 1 over 2 cos alpha, and this is all over sine of alpha, not so? You all agree with that? Alright, so that's all over sine of alpha. But what I can do is, that's all over sine of alpha. So what I do is I put each one over its own. You all agree with that? No, we did that in grade 8. Each one over its own. So what I got now is over sine of alpha over sine of alpha. So we have H over tan of alpha into. The first fraction, what's going to happen? Cancels. So it's going to be a root 3 over 2. Now what's sine of a cos? Tan. And cos of a sine? 1 over 10. Okay, let's see how far for me. You see there's a 2 on the outside in the denominator. So what are they actually doing here? They're taking out the half as a common factor. Can you see that, people? So if I take out the half as a common factor, so it's H over 2 tan alpha into root 3 plus 1 over 10 alpha. They have just proven what they wanted. Okay, so it's H over 2 tan alpha into root 3 plus 1 over 10. Okay. So any confusion there? Okay. Beautiful, huh? Too beautiful, you say. Alright, let's look at the last one. And the question says, if alpha, let me put this here, just in case you need that information. If alpha is equal to theta, which is equal to beta, use 6.1 to show that AC is equal to that story. Okay? So we don't need 6.2, so we delete that. We move him up. So let's go. Again with this formula here. Alpha is equal to theta, which is equal to beta. But what do I notice? What do I only have? Alphas. So theta will become alpha and beta will become alpha. You all agree with that? So therefore AC is equal to H sine alpha plus alpha over sine alpha tan alpha. That's alpha plus alpha? 2 alpha, not so. So this becomes what? It becomes a double angle. Double angle. And sine of a double angle can be written as 2 sine alpha cos alpha over sine alpha. You see there's no tan here. So what do you think tan, what's going to happen to tan? Becomes sine alpha over cos alpha. So what happens now? Sines cancel. Which now gives you 2h cos alpha over 1 must be divided by sine alpha over cos alpha, which is the same as multiplied by cos alpha over sine alpha. In nothing can cancel here, so 2h cos alpha times cos alpha is 2h cos squared alpha over 1 times sine alpha. That is exactly what they wanted us to prove. Okay. So if it's so sad, it's coming to an end now. No, it's okay, man. There's more to come. In another section, we do revision. People, we are told a rectangular block of wood. Hey, you don't even tell me I'm a stranger. So we are told that a rectangular charger where we sit in the dark. Right. A rectangular block of wood has vertices P, Q, R, S, T, U, V and W. The dimensions of the block, of this block of wood are the root of 200 centimeters, 12 and 5 centimeters respectively, 5 centimeters. A cut is made through the vertices QTV, revealing a triangular plane. So it's a flat surface there, which is TQV. Determine the magnitude. The magnitude is the size of TQV. This angle. Okay. There's a lot of calculations in this one. Okay, so looking at this here, you get this angle here. know the length of all three sides of this triangle. And then which rule are we going to use? Cos rule. Not so. So, we need to calculate the length of TQ, QV and TV. You all have an idea of how this looks? Okay. So we start off. We say intra-angle TPQ. So we have a triangle looking like this. This is a right angle triangle. It's a root of 200. That is P, QT. And this is 5. How do you think you can calculate QT? Yeah, QT. Pythagoras. The TQ squared is equal to 5 squared plus the root of 200 squared, which is 225. The root of 225 is 15. It's 15. You all okay with that? So intra-angle QVR with a triangle looking like this now. That is 12 RV. What's the length of RV? The same as this one. So your height of this object, which is 5. Apply Pythagoras. So QV squared is equal to 12 squared plus 5 squared. 144 plus 25, 169. Square root thereof, 30. Okay. So intra-angle WTV, so WVT. What's this length? The same as this length. The same as that length, which is 12. And this length here, the same as that length, which is the same as the root of 200. So TV squared is equal to 12 squared plus the square root of 200 squared, which is 144 plus 200. So they give you 344. Is that correct? The square root of that is not a perfect square. Sorry? 2 root 86. 2 root 86. You could have changed it to decimal if you want. 2 root. But I'll keep it in that form. Alright, so what do we have, people? We have 3 lengths. So that I can calculate any angle I want. Okay? We're applying the cos rule in that triangle. So we're working intra-angle TVQ. So we have a triangle looking like this now. That is T, so it's 2 root 86 V. Q, that is 13 and 50. If I want to calculate that angle, I must make 2 root 86 the subject of the formula. Can you see that? So let's write out the cos rule first. So it's TV squared is equal to TQ squared plus QV squared minus 2TQ times QV cos of T QV. Okay. So TV is what? 2 root 86 squared equals TQ 15 squared plus QV 13 squared minus 2 times 15 times 13 cos of TQV. So what I do is I take 15 and 13 over, so it's 2 root 86 squared minus 15 squared minus 13 squared equals negative 2 into 15 root times 13 cos of that angle. So I divide by this coefficient there. I divide by negative 2 into 15 and times 13 times negative 2 is equal to cos TQ. I work the story out. If this is negative, then this angle will be obtuse, which puts it in the second quadrant because the cos is negative in the second quadrant. But it looks like the spread is not so big, so I would assume it's going to be positive. But I could be wrong. It was positive and then just an acute angle. So it's 2 root 86 squared minus 15 squared minus 13 squared over negative 2 times 15 times 30. So it's 5 over 39. So cos TQB is equal to 5 over 39. So what does that mean, people? That angle is actually an acute angle, not so. So R cos of that makes TQB equals R cos, that answer, 82,60. Let's check if that is right. 82,60. Okay. I think I got 11, and I should be able to do this as well. Okay, now I'm not getting ideas now. But the reason why we won't probably ask it because it's 3-dimensional. Okay. Okay, any confusion here? So we're going to put exactly the same sum in the exam, in the problem. We have a problem. Alright. People, and the last question for this exercise was determine the area of the triangular plane. Now you're going to count so the area of the triangular plane, QTB. So is this here? Not so. So how do you calculate the area, people? What do I need? I need 2 lengths and an included angle. Do I have that? Yes. So the area is going to be half TQ times QV sine of TQV. So it's going to be half. Do I need to write the story out here? No. It's going to be half times 15 times 13 sine of 82,63. So it's half times 15 times 13 sine of 96, 7. Is that correct? Huh? 96,7 centimeters squared, as you can see. It's given in C. People, you guys understand? Okay, so that basically brings us to the end of exercise 4 on page 228. Okay. The revision exercise that follows, you guys can work through that on your own. If you have problems, you let me know. Okay. The full lessons can be found in the description box below.